why do we have waves? In the coastal system, or the coastal environment and associated landform processes, we are referring to surface circulation. So surface wave, we are not talking about deep sea ocean circulation. That's for another part in this topic about the ocean current. But for all the coastal processes, wave, erosion, deposition, transportation, and the resulting landform, we are referring to the agent as the surface wave. We need to start with the basic structure of wave. It's a little bit like physics, right? The wave crest is the highest point, so you won't be asked the definition, but you need to know what they are referring if you see the word in the exam. The wave height, how tall is a wave, is between the wave crest and the wave trough. Okay, so that's the wave height. The wave length, we're referring to distance between two wave crests or two wave troughs. Supposedly it should be the same in the open sea, unless it's approaching the shoreline where the gradient is getting shallower. Wave frequency is the number of waves per minute. Okay, so example, let's say if you stand near the coastline on the beach, then you measure the wave frequency by counting how many numbers of waves hit you in 1 minute. Okay, so the higher the wave frequency means the higher the velocity of the wave. Okay, and as a result, it's usually associated with higher wave energy. So if you remember in the river, we say high river velocity means higher river energy. It's like throwing a punch, right? If you throw it at a high speed, the impact is usually greater because the energy is greater, right? Higher wave frequency means higher wave energy, and it's usually more related to erosion or landfall, okay? Because if you remember back in the river, higher river energy means it's more likely to erode, okay? Then, if we flip it, the opposite would be lower wave frequency means lower wave energy, and is more associated with depositional landfall, or deposition itself, because the wave does not have enough energy to carry the sediment. So the sediment is deposit. Then the question becomes why we have waves, or what generates wave. So the answer is wind. So have you heard of the phrase 無風不起浪? There's a reason behind, right? You won't all of a sudden decide to argue with a friend or have conflict with a friend. There's something happened in the past, or something happened recently. Let's say if your friend, he or she probably did something that you do not like. Okay, so that's why you argue with him or her. Okay, so the metaphor is, it means that there's a reason behind every conflict. Okay, but literally in the case of wave, we say if we have wind, then we will generate surface wave. Let's say summertime, if you're in Hong Kong, you can and there's a typhoon. If you turn on the TV, you will see people, like the news reporter will go to like some coastal region and say, oh, now the waves are not too strong, even though it's windy. So they will report that. And you will always see some like citizen going to the coast and to observe the wave for some reason. So I don't particularly have that interest. But then the government, the news will say, oh, it's dangerous, don't go to the sea. But people still go. The stronger the wind, the stronger the wave. And that's why we have the storm surge, okay? So here, in the exam, most of the time, you'll be asked to talk about why certain landform is formed. For example, erosional landform. Let's say they give you a photo of a sea cliff, okay, and ask you to explain what are the reasons for the formation of a sea cliff. So most likely you should and would have start with strong wind, okay, or we have relatively exposed location to wind, and that's why the waves are generally stronger, okay, and that's associated with erosion, okay. So basically everything in the coastal environment, this chapter, originate from wind. Okay, so if we have weak or no wind, then it means it's more likely to have weak wave and low wave energy, and usually deposition. Okay, so later on we'll talk about some concept associated with wind as well.